a heartbeat, and surprisingly, even though we can't see it, we here on Earth move to its rhythm. We don't really understand why the sun goes through this cycle. It's clearly related to the magnetic processes that exist within the sun itself. Yet, although we have observed these cycles in action for the last 200 years and have seen evidence of their influence on the Earth over the last 10,000, we still no closer to figuring out why the sun cycle has a length of that particular time period, rather than any other. What force drives it? Lacking any other obvious answer, some scientists have tried to connect the orbital length of Jupiter, also about 11 years, to this cycle length. But this could easily be a coincidence, although Jupiter represents 2.5 times the combined mass of all the other planets in the solar system and definitely exerts some gravitational pull on the Sun. Its orbit cannot explain the variations seemingly random that the Sun's cycle undergoes. Much of what goes on within the Sun is a mystery to us, but its influence on Earth that is much easier to see. It begins with the space around us. Space is more and more important to modern civilization. So it shouldn't be surprising that CMEs and solar storms streaming out from the Sun more regularly would have an impact on the technology we have up there. Scientists are able to predict the arrival of a solar storm, known as a geomagnetic storm, by the time it arrives at Earth days or even weeks in advance. This allows astronauts to go into safe shelters to hide themselves from harmful rises in radiation levels, and also allows the delicate hardware on satellites to be powered down to prevent that hardware from being fried. This is important. A solar radiation can cause unexpected electrical currents to form in wiring, overloading systems that haven't gone into a safe standby mode. But there's another aspect to geomagnetic storms that you might not expect, or of that radiation has an impact on the atmosphere itself. It warms it, albeit just a little. As the atmosphere warms, it expands, and this has an impact on our satellites in space. There is no drag, so objects can orbit practically forever. Well, this isn't entirely true, and satellites in low Earth orbit do occasionally, about 4 times a year, need to expand fuel to correct their orbits, as there is still a tiny amount of atmosphere up there. But when a geomagnetic storm occurs, the atmosphere blossoms upwards, and low Earth orbit satellites have to maneuver every 2 to 3 weeks to keep from falling from the sudden friction. And this isn't always enough. In 1989, there was a geomagnetic storm that was so powerful it knocked the NASA's Solar Maximum mission out of the sky, as an increase in atmosphere suddenly slowed the satellite down. Ironically, the mission had been studying solar flares. This is not an isolated incident. NORAD, the Northern American Aerospace Defense Command, has to relocate hundreds of satellites after each geomagnetic storm, as they have been knocked out of their old orbits. Radiation can also influence our ionosphere, filling it with charged plasma. This can have a slight lensing effect on your GPS systems, reducing their accuracy from within a meter to over 10 meters the next time you look on Google Maps, and it thinks you might be a street across from where you are. A geomagnetic storm might be to blame. Our power grids brace themselves every 11 years for the uptake in these current-inducing events to keep themselves from being overloaded. Amateur radio enthusiasts and airline pilots find their high-frequency radio range dropping significantly as radio waves get deflected or even blocked completely by the more powerfully charged ionosphere. As I predicted in my horoscope, this all adds up to some less reliable technology. The fact that the next solar maximum is expected to arrive soon in 2025 makes me quite confident in my prophesying. There are some bright sides to this. As space weather becomes more turbulent, parts of the world, such as Canada, see a rise in the number of auroras dancing hypnotically across the sky. Aurora chases report rises in sightings from a few times a year to as many as twice a month during the most energetic parts of the Sun's 11-year cycle. So much for the sun's influence on space and our technology. You might think that that's the end of it. The sun cycle might influence machinery, but it's not going to make much difference on anything alive, right? Right, if you think that you'd be wrong, it's not for nothing that the rest of my horoscope mentioned poorer health. There's growing evidence that the sun cycles can even influence ecosystems and species themselves, including humans. Some of this is incidental when the Shab cycle is at the solar minimum. The sun exerts less pressure through its solar winds, which means, ironically, that we get less protection from our heliosphere from cosmic radiation. This form of radiation is highly energetic, but fortunately, rarely makes it through our atmosphere for that very reason, as it's likely to be absorbed or deflected by a passing air molecule. But reaching the atmosphere is all that's needed to produce an effect. There is a theory, although still far from certain, that this extra radiation could be creating nucleation sites in the atmosphere that seed extra clouds influencing our weather. Even if that's not occurring during solar maximum, the space weather hitting our atmosphere can raise global temperatures slightly, as my horoscope at the beginning predicted a warming of the weather, not by much. It should be said less than half a degree, and the temperature always eventually returns to where it started. But it's enough that it's noticeable to species, paying attention to temperature, for instance, to decide when to start. The mating season studies of birds have shown that on warmer years, they tend to lay eggs earlier. Curiously, a study published in